Well, now let's go ahead and focus on the second topic here, which is how do we solve more complicated inequalities? So these aren't just going to be simple linear inequalities, but things that involve either really large kind of strange polynomials or even rational functions. Now this is actually a surprisingly simple task and something that is typically covered in like an Algebra 2 or a pre-calculus course. So here's at least kind of the basic rundown of what we would do. So the first thing that I'm going to go ahead and do here, if I was to take a look at a question like 2a, is I'm going to note that if I want to figure out when this inequality is less than or equal to 0, that means I'm looking for all the values of x, any value of x that I could ever use, so that when I plug it in here and I crunch out this left-hand side, I get a result that actually is 0 or smaller. So typically what we start with here is we want to find when this particular expression on the left is going to be equal to 0 and when it might be undefined. So that's what we're going to start with. So I'll say that we see that the left-hand side equals 0 when, and I could start to simply explore this. When would it be the case that something times something squared could be equal to 0? That is, when will x plus 3 times x squared plus 9 times x minus 10 squared actually equate to 0? Well, since I have three things being multiplied together, it's really going to be at, well, whatever times, whatever values of x would make any of these individual quantities turn into 0. Because if any one of the three things in this multiplication represent 0, then definitely the whole product would be 0. So I can go ahead and quickly determine several values. If x plus 3 is going to be equal to 0, that would give me x would have to be negative 3. X squared plus 9 actually can't equal 0. That's not possible, because notice that even if I try to set this up, x squared plus 9 is equal to 0, then I'm going to get x squared is equal to negative 9, and there are no real numbers that could make this work. And again, we're only working with real numbers here in Calculus 1. So I can't get this x squared plus 9 to turn into 0. However, I can get my x minus 10 squared to be equal to 0, if x is equal to the value of 10. I'll also go ahead here and note that the left-hand side is never going to be undefined. There's no value I can plug in to force me to divide by 0 or do a square root of a negative or anything like that. So now what I can do is I'm going to go ahead and create a little bit of a number line. So I'm going to sketch out a number line here, and I'm going to put all the numbers that we just had on our number line. That is, I'm going to put down negative 3, and I'm going to put down the value of 10. Now I know that there is 0 is the output of my left-hand side. So notice here what I'm doing is on the bottom I'm using an x value, and then up top I'm computing what the whole left-hand side kind of turns into. So if I plug in negative 3, everything on the left becomes 0. If I plug in 10, everything on the left becomes 0. And now what I can do is I can use some test points. I can test some values in between these to see what this expression will become when I don't use exactly these values, but maybe say something smaller than negative 3, or in between negative 3 and 10, or even bigger than 10. So let's take a look at how that would actually work. Let's suppose that I pick a number down here over on this side. Like maybe I pick something like x is equal to, say, negative 4. Okay, I'm going to test that out to see what happens over here. Well, if I was to do that, I should be able to notice the following. If I plugged in an x equals negative 4 here, this factor is going to become negative. This piece here is certainly going to be positive because it's a squared value plus 9. That's always positive. And here, no matter what the inside is, the value is always squared, so this is positive. So I'm going to get a negative number times a positive times a positive. I know then that the result is going to be negative. And really, that's all I care about here. I care about the fact now that the numbers that I plug in over here, anything like a negative 4, negative 5, negative 10, doesn't matter, is going to create a negative result over here. Now I can go back and kind of reassess the same scenario here when I plug in different values. So what if I plugged in a value between negative 3 and 10? Make my life easy, let's pick a simple value like 0. Well, again, I should notice here that this second factor and this third factor are still going to actually be positive because it's a quantity squared and an item squared plus a number. So these guys are always positive regardless of the input. But I can see that over here in the front, if I do 0 plus 3, I'm going to get a positive result overall. A positive times a positive times a positive makes something that's positive. Finally, over here, I can choose something maybe like an x is an 11. And if I was to do this, I should also notice that I'm going to get the same set of symbols all the way across. So what I can see here is that my left-hand side will spit out a negative number. If I plug in a number less than negative 3, it'll spit out a value that is positive if I plug in something in between negative 3 and 10, or if I plug in something greater than 10. So now that I kind of understand how this left-hand side operates, I can think about answering the question. I was interested in finding every single time, every single value of x that would make this expression come out equal to 0 or less than 0. And so here would be my final solution. So I would recognize that the spots that make this left-hand side come out negative or 0 would be any number from negative infinity to negative 3. That's all of this spot over here produces negative outputs. But negative 3 is also okay, so I'm going to include that because that allowed it to spit out 0, and according to what I have here, I'm okay if I equal 0. Now there's one other value here that's acceptable, and that would be the value of 10. So to include that, I would go ahead and just kind of write this as one single individual value, like this. These are the spots where I'm going to get 0 back or negative numbers. And you could test this out very, very easily with just some at least small examples. Plugging in any number that fits inside of these intervals here into this expression would create a negative or a 0. So this is how I would tackle something like 2a. Now let's take a look really quickly at something like 2b and try the exact same idea, but now we're just going to be dealing with a fraction. Okay, but the same basic idea still holds. We're going to be looking when the left-hand side here could be equal to 0 and when it might actually be undefined. So I'll start by saying this. We see that e to the x times x squared over x squared minus 25 equals 0 when, well, let's think about this. If I wanted this to equal 0, I could start by taking my denominator, multiplying it over to the other side. I would get something like e to the x times x squared is equal to 0. Pretty obvious. If I want a fraction to be equal to 0, I need the numerator to be equal to 0. Again here, though, I have two things that are multiplied together that could equal 0. And so I can take a look at when this would actually occur. Well, notice that e to the x actually cannot equal 0 because if I think about just the quick graph of e to the x, again, it's one of our graphs to know, we should know it, I recognize that the x-axis is actually a horizontal asymptote of this graph, and therefore this function never hits 0. So it's not possible for e to the x to ever equal the value of 0. So, instead of writing that, I'll go ahead and actually just state then that to make this equal 0, I would need x squared to equal 0, which means that I would need x to equal 0. Okay, so I know when this thing could be equal to 0. Now let's see when it's undefined. So I'll say here, also, e to the x times x squared over x squared minus 25 is undefined when, well, this would be when, I guess, the denominator of my fraction would be equal to 0. And of course, if I think through that really quickly, that of course is going to mean that x squared could be equal to 25, which of course is going to give me two different values here. X could be equal to positive or negative 5. So again, I'm going to go ahead and make a little number line here to kind of test what's going on in this scenario. I'm going to go ahead and on this number line put down all the values that I found. So that is a value of negative 5, a value of 0, and a value of positive 5. On the bottom here, notice again I'm putting x's, and on the top side I'm going to compute what the left-hand side spits out. So we've seen that if I plug in values like negative 5 or positive 5, I get an undefined value for the left side. And if I plug in 0, I get an overall value of 0. Now let's just do some quick test points. Let's see what we come up with. Let's go ahead and plug in something maybe like a -10. That would tackle this region over here. If I was to plug in a value of like -10, the first thing I should note is that this numerator up here is again always going to be spitting out a positive answer almost regardless of our input, because e to the x always produces positive values, and a number squared is always going to be a positive or non-negative value. And so I'm going to be able to get a non-negative result. Let's say that the top here is definitely going to be positive. So really all I have to concern myself with is what the denominator is going to do. And notice if I plugged in something like -10, I could definitely tell that the denominator is also going to be positive. A positive number divided by a positive number is definitely going to be a positive result. But what if I plugged in something, say, like a +1 or a -1? If I was to do that, I would notice that my denominator would actually change to be a negative value, meaning that I'd have a positive number divided by a negative that would produce negative results. And if I plugged in something like a +10, I would recognize that again the bottom would become positive, and so I would end up with positive outputs for values above 5. So now I can look at what the question itself was actually posing, which is, when will this fraction spit out a value that is greater than or equal to 0? And so this here actually becomes fairly simple and straightforward to work with. I can see here in my solution that any value from -infinity up to -5 works, but I'm not going to be able to use -5 because that's not an okay value to plug in. It doesn't create something positive and it doesn't create 0. I can then see that I definitely want to include the single value of 0 because that spits out an output of 0. And I'm also going to want to include the values from 5 to infinity. So notice that I did pretty much the exact same work as what I did up above. The only difference is that I had to actually deal with some values of x that made this fraction undefined, whereas in the original part A, there were no values of x that made this expression undefined. Now, I'm going to leave part C for you to go ahead and try on your own, and remember that the solution for this is posted up online.